Okay, good. I got a question finally. I think this is actually a Bernoulli's principle here. It says, why does your car get pulled sideways when a truck passes you going in the opposite direction on a two-lane highway? I don't know if you've ever felt this, but if you're driving down a highway, so here's the highway and here's the dotted line, and so maybe this is you and your car going that way, and then there's, particularly if it's a big truck going that way, and right as you cross, it not only feels, but it literally is pulling the car over into the truck. That's why teaching someone to drive at the beginning, especially if they learn to drive in a big city where you don't get these, narrow two-lane highways that then they pass at high speeds. And so the first time you're on a highway at high speeds, hopefully somebody will coach you, educate you, hold on tight to that wheel. Because when you get next to that car, it's gonna, pull you in, and so you want to fight it back, and you want to keep that wheel straight, and maybe even you'll have to turn the wheel this way to put a force that way, because as we're about to talk about, there is a force. It doesn't just feel like it. There is a force sucking you in, and it comes from Bernoulli's principle. So going back to Bernoulli's principle says that the pressure would decrease as the speed of the air increases. So if you were to look at this car going down the road without anything else around it, it would be running into all these air molecules, and you would roughly get an equal flow on the left and the right of the car. And this flow would make a lower pressure, but it would be a lower pressure on each side of the car. And so if you think about the air on, and I'll pretend I'm driving this way here, so this would be my left side, so the driver's side here, and over here I'm on the right side, they would be, the air would be pushing in. Now, granted, it's not as pushing as if I came to a stop. Now, if I came to a stop, the pressure would be greater because, again, this is Bernoulli's principle. The faster the air moves, the lower the pressure. But what's real important here is the differential between the left and the right. So there may be, I'll put high and high pressure, but they're equal. And so there's no net effect. And we often forget about a car just sitting there. It's actually getting pushed from the left by the air. It's also getting pushed from the right. And because those two balance, we don't think that the air is actually pushing on it. But there is quite a bit of pressure on that car and quite a bit of push. And if one of them was removed, it would actually push the car. The same thing can be said about when the car is now moving. Now, granted, it's lower. So I'll put lower and lower. And again, if you're just driving your car with nothing else around, the flow of the air is roughly equal on both sides, and it lowers equally on both sides. And so you have a push. Granted, it's a lower push, but the real key is it's an equal lower push, and there's no net effect left or right. So if you're in your car just sitting, you go, yeah, the air's not pushing me. You're in your car driving, you say, yeah, the air's not pushing me. It is pushing, but it's pushing equally left and right, either left and right with a high force or left and right with a low force. Here's where it gets then when something finally is different. And so if you're driving the car and the air is trying to flow around the car, and then there's a truck that blocks that flow of air. What ends up happening is this narrow cavity between the car and the truck forces the air to be pinched, if you will, and it's got to squeeze through this little area much faster, or squeezed and it goes up. But whichever way the air goes, it's got to flow faster. And in the fact that it flows faster, you get a low pressure on this side, whereas this side, you still have this, I'll just still call it lower pressure, because lower than if you were stationary, but not as low as the left-hand side. So now, is when you feel the effect of the air pressure. Because and again, I'll pretend I'm driving this way. So now I would have this low pressure, or lower pressure, pushing me in the picture, I guess, would be down. And I'll call it left still. So in my car, this would be pushing me left, pushing me into the truck. And then this one here is pushing back, but not as much. And so the net effect is a push towards the truck. And you didn't have that when you were just driving without the truck nearby. Or you didn't have that when you were stationary. You only had it now that the truck has got next to you and forced the flow of air to be much, much faster in order to squeeze through this narrow space, and therefore a low pressure. And so a net effect to the left, which is into the truck. That's why you want to make sure you grab that steering wheel and go, oh, turn back, turn back. So hopefully that helps. It's a Bernoulli's principle.